everyone, welcome to the session. So now we are quite towards the ending part of our project, and congratulations, we did so far pretty well. We have understood all the phases, and now it's the right time that we will try to understand the model evaluation part. Although now, after this part of the videos, you will find it pretty much easy because the, I would say, important, crucial, and maybe bit ambiguous part is already we have done. So now you will see that a lot of things we already did. We created the model, we did the prediction, but now it's the right time to evaluate that okay, the best model that we are getting, how much is the accuracy, how much is the F1 score, and we can maybe add few things or delete few things according to our needs. So let me go to the start model evaluation class method. So here you can see that we are calling this model evaluation. So now I am jumping towards this model underscore evaluation file. Here you can clearly see, right? We are, passing the artifacts of data ingestion, model trainer, data transformation, and we are passing the config file of model eval. Here what we are trying to do, just try to understand. We will be able to get the best model because now we will be having a best model in our model trainer file, and we can directly extract that. That is completely fine. So we can see that if the model is present, we will be able to take that model path and we can return that customer cluster estimator. The important thing is this that we are trying to do here, this one. What we are mainly trying to do here, once we will be able to get the file, what we are trying to do, we are trying to do the prediction on the test data. Once we will be able to get the predictions, which we are talking as a y-hat trained model, right? What we're trying to do, we want to, check the F1 score. So what is the F1 score? We can directly call, right? Similarly, we will be able to calculate the metric. Similarly, we will be able to calculate all the stuffs that we want, like accuracy, is model accepted or not, best model metric, best model F1 score, trained model F1 score. So if I'll go here, so you can see that these are the parameters, or I would say the variables that we have defined in the class of evaluate model response. So here, basically, our evaluation will contain, initially we have defined the float values of trained model F1 score, best model F1 score. So basically, when the model will be accepted. A simple thing, I'm asking one simple question. When the model will be accepted? Obviously, when we will be having a accuracy of the best model, current best model, to be high as comparable to the already present, previous model file. So if we don't have, then obviously that will be not accepted. Changed accuracy or not, best model metric artifact. So that is what we are trying to do here. So here, that is what we are trying to do. So let me try to now explain to you what I am saying here in a PDF itself. So what I'm saying, or what we are trying to do here in a nutshell, is that obviously we will be able to get the best model. Now consider I am taking one simple accuracy parameter here. Okay, just try to pay attention. You will be easily able to understand the context behind what we are trying to do here. So suppose I will be having a accuracy here. Okay, I will be having a accuracy. Fine. Now at each and every time we are hitting that model factory, we are trying to get a best model. So what we are trying to do is that we are trying to, store the pickle files of the best model inside something called as S3 bucket, right? S3 bucket. Just give me some time. So here, let me create one bucket. So here I am trying to, maybe M1 model is there, then M2 model is there. I'm just, just trying to explain the things. Please try to grab in terms of understanding. M3 is there. Now, what I'm saying is that maybe this is the updated one, pickle file. But I will check, right, that the prediction of this particular best model, which I recently get, which is M3, okay, is this predictions or is this accuracy is higher as comparable to the previous one, M2? If suppose that's not the case, then obviously on the deployment part, what I want to push on the prediction side, suppose here on the deployment part, on the production side, there is another bucket that we have, that's the real purpose of model pusher, which I will explain in the next class. But please try to understand the context here. So here for the prediction, obviously we will be having maybe several files inside the S3 bucket at the time of training. When I'm applying a best model, at every time when I'm hitting, maybe I will be able to get the pickle files. I'll try to do the comparison that currently whichever the best model my model is saying, is the accuracy of that model is higher as comparable to the previous one? If suppose yes, so I will push M3 here for the prediction part. If suppose no, then I will push the M2 here. That's the real purpose of model pusher, right? Because what I want, what I really want, what's my real target is to get a higher accuracy. So here if you will try to see, here you will try to see that we are trying to pass that S3 model key path. So here I'll show you while, showing you the demonstration of how the training is coming up and how the prediction is going to happen in the next particular part of the videos. So we have to define that, okay, where you are storing that model path. You have to define the bucket name inside the S3 bucket. And then that is where your pickle file and your model, I would say, will be saved, right? And then maybe you can evaluate that. And then you can just try to compare that. You can calculate the metric, you can calculate the F1 score, you can calculate the best model predictions. I hope I'm making sense now. And finally, whatever result you are getting, on the basis of that, you will try to just print the result. You can just try to get the log information for that, right? So we will be able to get trained model F1 score and we will be able to get the best model F1 score. So it might happen that both of them are same, because just now the model that you have trained, that will become your best model itself. At that point of time, you will be getting the same F1 score for that, but they can be different as well, right? So is model accepted or not? So I have written, right, when the model will be accepted, when the current trained model F1 score is bigger as comparable to the temp best model score. Similarly, how much is the changed accuracy? What is the current accuracy I have minus what is the previous one I have? Similarly, what is the best model metric artifact? Here we are trying to store the best model artifact only. So this is how basically we will be able to get the result, and that is what we are trying to store it here. I hope that I'm making sense to everyone. Here, in a nutshell, we are trying to train the model, getting the best model, getting the predictions of that, getting the F1 score for that. After that, we will be having a best model. We will be calling the function called as get best model. Again, that model factory will be hitting and it will generate the best model out of the given models that we have. And again, we are trying to do the prediction for the best model as well. And then we are trying to do the comparison between the best model F1 score and the trained model F1 score. And whichever is bigger one, that will become the final one, which will go for the model pusher for the predictions part. I hope that I'm making sense to everyone, right? So that is something which I really want you guys to make you understand. And this is how basically the model evaluation will happen. And finally, if that is done, the real final task is to initiate the model pusher. So let me do one thing. I'll not try to go inside that part as of now. So we are good to go with the start model evaluation part, and we have seen that what is happening there. So obviously we need to pass on the artifacts for ingestion, trainer, and the transformation. Now the final thing is model accepted? If the model is accepted, then it will be true, otherwise it will be false. And finally, if that is accepted, when it will be accepted, I hope now everyone knows. If the current trained model accuracy or the F1 score is bigger as comparable to the previous one, so it will be accepted. And at that point of time, what we need to do, we need to start the model pusher. So that is something which will be going to do the predictions for the upcoming records that we have. So I'll talk about the start model pusher in the next upcoming part of the video. With this, let's end this video. I hope that this part is also pretty much clear to everyone. And I'll see you all in my next upcoming video.